Ladies and gentlemen, welcome to today's lesson about scatterplots. We're starting a brand new unit today. Our last unit is about univariate data, as in data sets with only, one list of data, and they're all about the same thing. To a unit that's bivariate data, meaning it's two sets of data that are matched up. And let me kind of show you what that looks like. So you should get out your assignment, Scatterplots intro, and go to this problem. This is an example of some bivariate data. So a history teacher asked the students how many hours of sleep they had and matched it up with their test scores. So there's a student that got 8 hours of sleep and scored 83%. And there's a student that got 7 hours of sleep and got 86%. And later on, you got someone who slept 4 hours at night and got 60% of their test. And that's bivariate. Those are matched up, right? We can't we can't switch these around because they're from the same person, so they're matched. And what that does is when you have this matched up data, this bivariate data, you can turn it into a graph. Each matched up pair of numbers makes a point on a coordinate grid. And so when you plot all these points, it makes something called a scatter plot. And I'll explain why it's called that in a second, but you'll probably see it. So this is the point 8, 83. So I go to 8, 83. This is going to be about here. There's not a grid line there, so we're going to put it about where it belongs. The next one's 7, 86, just a little bit above 85. And go through the rest of these and make your scatter plot. Just doing one point at a time and see if you can get yours to match up. Pause the video, draw the rest of your scatter plot. All right, let's have you check and see how you did. Yours should look like this. And all I did was plot these points, right? You got the point 4, 60, so I went to 4, 60, and put a point in, and this and that. And it makes a graph look like this, which is a collection of points. This is called a scatter plot because it's a bunch of points scattered on a plot. I know, it's really original. Sometimes mathematicians have great names for things. But yeah, that's the idea of a scatter plot. You take the data, you turn it into points, put it on a graph, and voila, you have a scatter plot. And so that's a good portion of your assignment. It's just looking at that. There's another thing on your assignment that's asking about. It's this idea of correlation. You got your vocab word of the day. A correlation is telling you how closely those points on your scatter plot follow a particular pattern. And so this example here, we have a lovely scatter plot. These points are fairly close together, and they have this upward trend like this. This would have a positive correlation. Notice the points are going up as you go left to right. And this would be fairly strong, right? There's a definite pattern of as you go right, it goes up. The points follow that pattern. That is a strong positive correlation. Something like number 2 here, the points are going down as you go left to right. Well, that'd be a negative correlation. Let me write that, correlation. And you may notice that these are a little bit more scattered. They do go down as you go left to right, but it's a little bit more scattered. So this would be kind of like a moderate negative correlation. If this is perhaps even more spread out, something like number 1, we would say this is a no correlation, right? There's not a definite pattern with the points as you go left to right. It's kind of just all over the place. So that would have a negative correlation. Well, the idea of correlation is that data points do follow patterns, and what kind of pattern you have can tell you a lot about situations. So there's different situations where there's a positive correlation or negative correlation or perhaps no correlation between the two. And these relate to things in real life. And so in this section here, it gives you a bunch of situations. You may have noticed I cut a few out. But on these, you're trying to decide, well, with the numbers, if one number goes up, does the other one go up? Or if one number goes up, does the other one go down? And that tells you whether it's going to be a positive or a negative correlation. And so that's what the section is about. You're saying if it's positive, negative, or no correlation between the two variables. So you got 8 here. The number of hours a person has driven, say I've driven in my life 10,000 hours, or maybe someone who's just learning to drive, maybe they're 16, they've only driven 50 hours. And then the number of miles driven. Well, if someone's been driving longer, like me, maybe I have a few thousand hours of driving, would I have driven more miles than someone who's only driven maybe 20 hours in their life? Would they have driven less far? Well, that one's going to be true, right? If I've driven 1,000 hours, I've probably driven a lot more miles than someone who's only driven 20. And so we're looking at something like a positive correlation. And I know you can think of like counterexamples. Maybe someone only drives 25 miles an hour. They could be driving for a long time and not nearly go as far as someone who drives 80 miles an hour up and down I-15 all day long, right? So there are counterexamples, but as a general trend, that's kind of where you're looking at, a general trend, the longer a person's driven, usually the more miles they've driven. And then 9 here, the number of siblings a student has and the grade they have in math class. I want you to give your best guess on this. Do you think there's going to be a positive, negative, or no correlation between these two numbers? All right, I kind of like this question in class a bit more than, if I'm telling it to you. But I like it because people have good explanations why they think positive or why they think negative, right? Some people might think, oh, if you have more siblings, then your older siblings can help you out with your math. Or maybe if you have more younger siblings, they distract you and annoy you and they make it so you can't get your homework done. But as kind of as a general trend, the number of siblings they have is not really related to what grade you have in your math class. So you're looking at no correlation here. Let's move on to another example. And there's more in here that you should do. But I want to jump down to this last one, right? The age of a house and the number of people living in that house. Again, I want you to kind of pause, take a moment to figure out, should it be a positive correlation? As a house gets older, do more people live there? Or is it a negative correlation? As a house gets older, do less people live there? Or no correlation, I guess. All right, on this one, I find this one, I would say it really does depend, and that's why it's kind of quite a question mark. I like this one because that's kind of ambiguous, right? If this is a brand new house, someone has built a brand new house, they move in, right? They start having kids, and then the number of people in that house is going to go up, right? Years go on, the number of people in the house goes up as people have more children. But then, as time goes on, those children start getting old, they graduate from high school and move out of the house, and then the number goes down. But, maybe someone sells their house at a certain time. Maybe they max out, and then they sell their house, and then someone comes in who had a little bit less children, but they start having more. It could be a pattern of positive correlation, or it could be a pattern of negative correlation. The number of people in the houses kind of do this. Which is going to be a no correlation. You think I just spelled correlation, right? But it really does depend on what kind of time period you're looking at for that house. There are sections where it's positive, and there's sections where it's negative. I usually had to know, it kind of just depends on where you're at in the house, age, and things like that. And so you're sitting at more of a no correlation because it depends. And if that's the case, then you're sitting at no correlation. And there you go. So there's a few examples on your assignments. You got more where you need to plot your scatter plots. And I wanted to mention that on these ones here where it has 2 tables, these are the same data set. You're just putting all these points on here and all of these on here. It's the same data set. They just put them in 2 columns. But yeah, there you go. Go ahead and make your scatter plots. Mention if they have positive correlations, negative correlations, or no correlations. It can be strong and weak correlations. It can be moderate correlations. And good luck with your assignment.